This is a hands-on class, so open the lab guide and code along with me. Last class, you learned the foundations of shell, scripting and AT-hen-to étoile fall, the shebang, variables, input, conditioners, and loops. You can now write a script that does a real job. Today, we make those scripts robust and powerful, the way a professional writes them. 3 ideas do most of that work. Functions let you organize a script into named, reusable pieces instead of one long wall of commands. Exit codes let a script actually know whether each step succeeded or failed, and 82 POV, which is the difference between a script you can trust and one that plows blindly ahead after something has already broken. And pipelines let you connect small, single-purpose tools into powerful one-line workflows, which is the very soul of the Unix philosophy. By the end of this class, your scripts will be organized. They will fail loudly and safely when something goes wrong instead of causing silent damage, and they will harness the full composability of the command line. This is the leap from writing scripts that happen to work to writing scripts you would trust to run unattended on a real server. Let us write some robust code. Here is what we will build today. First, functions. Second, exit codes. Third, checking the status of a command. Fourth, chaining commands together. Fifth, pipelines. And sixth, the habits of a robust script. Let us begin. Let us start with the tool that keeps scripts organized as they grow, the function. A function is simply a named block of commands that you define once and can then call by name as many times as you like. Instead of writing the same 10 lines in 3 different places, you wrap them in a function, give it a clear name, like n8200, backup underscore folder, and 8200 in200, and then just call that name wherever you need the work done. The definition lives in one place. The uses can be everywhere. The payoff is exactly what you would hope. No copy-paste, which means no drift, and A212, you will never have 3 slightly different versions of the same logic that fall out of sync. And when you find a bug, you fix it once inside the function, and every place that calls it is fixed at a stroke. A well-named function also documents itself. Leading n8200, check underscore disk underscore space in 8200 tells you what that line does far better than 10 raw commands would. Functions can also take arguments, just like a whole script can. Any A200 was inside the function. $1 and $2 refer to the values you passed when you called it. So a single n8020 greet n8021 function can greet any name you hand it. This makes functions genuinely reusable building blocks, not just labeled chunks. As your scripts grow beyond a few lines, functions are what keep them readable, maintainable, and sane. So the takeaway, a function is a name block of commands you define once and call by name many times, optionally with arguments and AT112, eliminating copy-paste, letting you fix a bug in a single place, and keeping a growing script readable and maintainable. Now the concept that turns a script from hopeful to reliable. The exit code. Here is the key fact that many beginners never learn. Every single command, when it finishes, returns a number called its exit code. That number is the commandant name's report on how it went. And the convention is universal and precise. An exit code of 0 means success and 812 everything went fine and 212, while any non-zero number means failure of some kind. 0 is good, anything else is a problem. It feels backwards at first, but think of it as NA 2020. 0 errors, NA 2021 being the good outcome. This matters enormously because it is the mechanism by which a script can know what actually happened. Without exit codes, a script is blind. It runs a command to copy a critical file and then just carries on, and 82 fall, whether the copy worked or failed silently. With exit codes, the script can check an A200, did that copy actually succeed, and A200 and behave accordingly. It is the difference between driving with your eyes open and driving with them shut. Non-zero codes can even carry meaning, and A212. Different numbers can indicate different kinds of failure, and A212. But the essential distinction you will use 99% of the time is simply 0 versus non-zero. Did it work or did it not? Every command you run, from copying a file to starting a service, is quietly handing you this verdict. Learning to read and act on it is what separates a robust script from a fragile one. So the takeaway, every command returns an exit code when it finishes an A212. 0 means success and any non-zero means failure and A212. And this simple verdict is the mechanism that lets a script know whether each step actually worked. Instead of running on blindly, knowing that commands return exit codes, the next skill is reading and acting on them. The direct way to read the exit code is the special variable $?. Immediately after any command runs, $? holds that commandant 2D9's exit code. So you can run a command, then check an A220 is $?0 A220 to see whether it succeeded. It is the script in IDA's way of asking an I2pasik, how did that last thing go? And I2pasik kasik, and getting a straight answer. One caution, it reflects only the most recent command, so check it right away before running anything else that would overwrite it. In practice, though, you often do not even need $? Because the if statement understands exit codes directly. Remember from last class that if runs its block when a condition is an A20 at 20, true an A20 and I20 and A20, and under the hood, an I20 A20, true an A20 and I20 and I20 and I20 end means an exit code of 0. So you can write an A2 HEU if an A2 200 followed directly by command and the block runs when that command succeeds. 8020, if this backup succeeds, then log it, otherwise alert someone. 8020 the exit code drives the branch automatically. This is how a script reacts intelligently to reality. A deployment script checks an 8020 did the build succeed. 8020 before it deploys. A backup script checks an A200 did the copy succeed, an A200 before it deletes the original. Acting on exit status is what lets a script stop safely at the first sign of trouble, instead of compounding one failure into a disaster. Read the status, then decide what to do. So the takeaway, the variable $? holds the exit code of the command that just ran. But you can also put a command straight after if an A212, since success is exit code 0 and A212, so a script reacts to what actually happened and stops safely at the first sign of trouble. Exit codes power a wonderfully compact way to express logic, chaining commands with $& and double pipe. The $& means and A200 and then only if that succeeded, and A200 when you write command 1 $& command 2, the shell runs command 2 only if command 1 returns success and A200 exit code 0. It is a one-line way of saying NA2020, do this, and if it worked, do the next thing, NA2021, for example, change into a directory, and then only if that worked, run a build there NA2012, so you never try to build in a directory you failed to enter. The double pipe is the mirror image, an A225, or else, only if that failed, an A2258, when you write command 1, double pipe, command 2, the shell runs command 2 only if command 1 failed, and A225 A25 on A25. This is perfect for fallbacks and alerts. Try something, or else print an error, or else send a notification. A220, deploy, or else rollback. In A221, the failure path is expressed as cleanly as a success path. Together, these two operators let you build real conditional logic right on the command line, driven entirely by exit codes without a full if block. You can even read them almost like English. RA200 ID6, make the directory and then move into it, or else report that it failed. RA200 ID6 to ID6 time, they are compact, expressive, and everywhere in real scripts and documentation and 8112. So recognizing and using them fluently is a genuine mark of command line competence. So the takeaway, chain commands by the exit codes and A212 $& runs the next command only if the previous one succeeded. and double pipe runs it only if the previous one failed, and A212 giving you compact and then and or else logic without writing a full if block. Now we reach one of the most beautiful and powerful ideas in all of computing, the pipeline. A pipe N82A2A2, written as the vertical bar character N82A2A2, takes the output of one command and feeds it directly as the input of the next. Instead of a command printing its result to your screen, the pipe redirects that result straight into another command to process further. You can chain several together, each one transforming the stream a little more, so the data flows through a series of small tools like water through a series of filters. The reason this is so powerful is the philosophy behind it. Build small tools that each do one thing well, then combine them. Non-command lists files, another searches text, another counts lines, another sorts. None is very impressive alone. But pipe them together and A200, R200, R200, list the files, search for a pattern, count the matches and A200, R200, and in a single line, you have built a custom tool that no one wrote in advance. You are composing a bespoke solution out of simple, reliable parts on the spot. And it is efficient too. The data flows through in memory from one command to the next with no temporary files to create and clean up. This composability is the very heart of the Unix philosophy, and it is why the command line remains so astonishingly powerful decades on. Once pipelines click for you, you stop looking for one giant program to do a job and start assembling the job from the small tools you already have. That shift is a superpower. So the takeaway, a pipe feeds one command and a teen idea output directly into the next command and a teen idea as input, letting you chain small single-purpose tools into a powerful custom one-liner and idea to hove efficiently. With no temporary files and 8122 wall, which is the composable heart of the Unix philosophy. Closely related to pipelines is a technique for capturing a command in D9 output into your script, command substitution. The syntax is a $sign followed by the command in parentheses. When the shell sees that, it runs the command inside and then replaces the whole thing with whatever that command printed. So where a pipe sends output onward to another command, command substitution captures that output and hands it back to you as a value. Writing your script. The most common use is storing a command in 300, so result in a variable. You might capture today N39 as state into a variable to build a timestamp file name, or capture a count of files into a variable to decide what to do next. Now your script is not just running commands and A200 file, it is using their results to make decisions and construct new commands. The output of the system becomes data your script can reason about. Discloses an important loop. Variables store values, input brings values in, and command substitution lets the results of commands themselves become values. Combined with functions, conditionals, and pipelines, it means your scripts can inspect the real state of the system N85 how much disk is free, which files exist, what time it is, N85 and act on it dynamically. That is what makes a script feel less like a fixed recipe and more like a small adaptive program. So the takeaway, command substitution in A212, a $sign with a command in parentheses and A212, runs the command and replaces it with its output, letting you capture a command in 9A39, result into a variable, so your script can use the real state of the system to make decisions. Let us pull these together into the habits that make a script genuinely robust and 8212 safe to run unattended on a real machine. The first habit is to put N8200 set-EN8200 or 200 near the top of your script. This tells the shell, the moment any command fails and A2112 returns a non-zero exit code and A2112, stop the entire script immediately. Without it, a script sails right past a failed step and keeps going, often turning a small problem into a catastrophe. Imagine a backup that failed, followed blindly by a command that deletes the original. Set-E turns that silent march into an immediate, safe halt. The second habit is NA2120 set-U AA2121, which makes the script error out if you ever use a variable that was never set. This catches a classic, dangerous bug, a typo in a variable name, or a value that never got assigned, which would otherwise expand to nothing and make a command do something wildly unintended, an A21N12K, like deleting from the root of the file system because a path variable was empty. sec-u refuses to run blind on missing values. And the third habit is to return meaningful exit codes from your own scripts and functions, and 8-end-NT1, exit 0 when you truly succeeded, and a non-zero code when you did not. This is you being a good citizen. Whatever calls your script, whether a person or another script or an automation system, can then check your exit code and know whether to proceed. Fail loudly, stop safely, and report honestly. N81 half. Those three habits are what let people trust your automation with real work. So the takeaway: write robust scripts with 3 habits. N8212. Set -e to stop instantly on any failure. Set -u to catch unset variables before they cause damage. And return meaningful exit codes so whatever calls your script knows whether it truly succeeded. Before we recap, let us see how these pieces combine, because their real power is in how they work together. Picture a small deployment script. It defines a function to build the app and another to run the tests, and 8212. That is organization through functions. It starts with set-e and set-u, so any failure or missing value halts it safely, and A202 that is robustness. It calls the build, and only if the build succeeds does it run the tests, using and then chaining, and A202 that is exit codes driving logic. Then it captures the current git commit into a variable with command substitution to tag the release, and it uses a pipeline to filter the test output down to just the summary line it wants to log. Each technique from today is doing one clear job, and together they form a script that is readable, that stops the instant anything goes wrong, and that composes small tools into exactly the workflow needed. This is what real scripts in real DevOps work look like. N8112, not one giant blob of commands, but organized functions, guarded by safety settings, wired together by exit codes and pipes, using the system N89's own output as data. None of the individual pieces is hard. The skill is the habit of reaching for the right one and combining them cleanly. Practice that, and you can automate almost anything on a Linux system with confidence. So the takeaway: real scripts combine today in D39, SES tools, and 8112 functions for organization, set-e and set-u for safety, exit code chaining for logic, and pipelines and command substitution for composing tools and using the output N80IT5, each doing one clear job so the whole script is readable, safe, and powerful. Let us gather the whole class in one breath. Functions are named blocks of commands you reuse, so you fix a bug in just one place. Exit codes report how a command went. Any A2 of L, 0 is success, any non-zero is failure. $? Holds the last exit code, and if acts on it directly, an 812 tell, branch, or stop. $& runs the next command on success, double pipe runs it on failure. A pipe feeds one command in 399's output into the next, composing small tools into big ones. And robust scripts use set-e, set-u, and meaningful exit codes to fail loudly and safely. Next class, N8282 Git, the foundation of version control. One idea at a time. That is shell scripting